You've seen them and you love them, the exuberant and colourful coral reefs. Today we're going to journey inside a reef to show you some stuff you've never seen before. Corals are some of the smallest animals in the ocean, yet they are responsible for the largest structures ever built by life. From the Great Barrier Reef to the 50,000 square miles of the Bahamas bank where we are today, on the island of Bimini.
And because corals reproduce by cloning exact replicas of themselves, coral animals are perhaps the oldest living creatures on Earth. So we're going to slow down and take a really close look at everything we see down there in order to better understand what we're looking at whenever we dive these amazingly complex habitats.
Now, it's a common misconception that rainforests are more biologically diverse than coral reefs. That's not necessarily true. The diversity of rainforests centers around their 30 million species of insects, bugs.
As a matter of fact, coral reefs have more invertebrates than do rainforests. And coral reefs have more of the major animal groups than any ecosystem on Earth, land or sea. You know, as divers, we find this complexity exhilarating, but we can also find it bewildering and even chaotic. As land mammals, we have no context for understanding all this weirdness down below. It's like we've landed on an alien planet. You know, as divers, we can naturally start to lose interest in something we don't understand, unless we start to gain enough knowledge that we cross that perceptual divide where we start to understand that coral reef, and by understanding it, come to appreciate it and want to know more and more.
When we return, we're going to cross that divide and begin our journey inside a coral reef. Now, the best way to appreciate a coral reef is to do a 24-hour dive and watch it during its typical day. Now, as we're not Supermen and this is television, that's exactly what we're going to do. Well, it's dawn here on Bimini. It's a really special time on the reef. It's that transition time when the nighttime creatures hand the reef over to its daytime inhabitants. Let's go and have a look as we start our 24-hour dive on a coral reef.
Day dawns quickly in the tropics. As light begins to spread across the reef, nocturnal creatures disappear and are replaced by daytime predators. They cruise for an early morning snack and include the barracuda, sharks, and other ocean-going fish. As day grows brighter, the fish seem to multiply, shoaling together or darting around the corals as they feed, while trying not to become someone else's breakfast. Each creature, from the smallest shrimp to the biggest grouper, begins to work the reef in its own way to make a living. Grazers such as butterfly fish and angelfish emerge from their nighttime shelters to nip at corals and sponges. Other grazers include parrotfish, named for the powerful beak used to scrape at seaweed that covers much of the reef's surface. Without this cleaning, seaweed would soon overtake the reef, smothering it. Damselfish of all varieties are also algae grazers. They farm seaweed in their reef homesteads and defend it zealously from all comers. Surgeonfish and tangs are also algae grazers and are the most common reef herbivores. Turtles like this hawksbill graze on sponges and algae until a human shows up, then it heads for the deep. Triggerfish specialize in grazing on urchins and are specially adapted to deal with its dangerous spines. Another group active in the mornings, plankton feeders, like these anthias fish of the Pacific. Staying in huge schools for protection, they feed on current-swept plankton, usually invisible to the human eye. Some of the ocean's largest creatures are plankton feeders, from whales to these manta rays, with mouths open wide like scoops. While those algae grazers and plankton feeders are making a living above the reef, there's a whole new cast of characters down below who are doing the things that all animals do. The three things that explain 99% of animal behavior: eating, protecting themselves, and having sex. What a life. Let's go take a look at some of these bottom dwellers, many of whom camouflage themselves. So we'll have to look close and know what we're looking for. Let's go. Inching across the sandy bottom is another group of grazers, sea cucumbers and conchs. Since bottom animals lack the reef for protection, many disguise themselves with the ability to change their colors and brightness. The peacock flounder, for instance, can blend in almost instantly wherever it lands. And what's the deal with those eyes? Simple. If you're lying face down, how well can you see? Not very well. So flounders have eyes literally in the back of their heads in order to watch for predators, like this lizardfish with its razor-sharp teeth, just waiting for flesh. Some bottom dwellers dig burrows, like these garden eels and also the yellow-headed jawfish. Jawfish mate for life, but the male and female live separately in adjoining burrows. A hermit crab lives inside a discarded shell and often takes a piece of sponge and attaches it to its shell in order to further disguise itself. Camouflage can be used for a less benign reason, lie-in-wait hunting, like this octopus mimicking a bright piece of coral. The long lure frogfish sits on a piece of sponge and becomes virtually indistinguishable from it. Can you see this fish? If not, you could become its breakfast. Patterns on this flamingo tongue can help it blend in with the reef's colorful background. And one of the reef's best camouflagers is the seahorse. Look how it has mimicked the color and patterns of the veins on this green gorgonia. Here is some rare footage of mating cuttlefish, which can change colors faster than any other animal. To mate, the male and female wrap their arms around each other. The male uses a special arm to place his sperm packets on the skin of the female. Later, she takes the sperm and inseminates herself, if she chooses. She can throw away sperm packets that are duds. Unfortunately, both the male and female die after one mating season. Should color be a consideration whenever choosing your tropical dive gear? We think the answer is yes, and it has to do with safety, not fashion. Because of a neon's higher wavelength, it marks you better underwater than does a non-neon color. Yes, I know that navy frogman black is the color de rigueur these days, whether in a wetsuit or a BC or whatever. But we think that neon should be on your gear, from everything from a BC to a dive booty. Why? Because it's that neon that's going to show up, especially when it's a dive booty or a fin, because of the movement underwater will help broadcast that color throughout the water at depth. And usually that'll be the first thing your buddy sees whenever he or she is looking for you.
Other considerations for your tropical gear setup might be that because you're using less neoprene, you'll actually need less weight, so take advantage of that perhaps and use a smaller, lighter BC like this one here. It'll need less buoyant lift than you would do in that cold quarry back at home, okay? Trouble with BCs are always easier to pack. Now, speaking of light, if you know you'll be mostly doing boat diving, why don't you use full foot fins instead of those open heel ones that require booties, like David's here, that become incredibly more stinky as the trip goes on.
And an extra bonus, according to Rodale Scuba Lab test, open heel fins are less efficient than full foot fins of the same model. Another reason to consider full foot fins for your tropical gear bag. Since you'll be wearing less neoprene on your tropical dive vacation, you'll need to protect your waist and your back from the lead that you will be strapping on. There are two ways of doing that. One is a padded weight belt, which is much easier to deal with than one of those long pieces of web strapping. But they also, especially when they're padded, protect your hips and your back a little bit more. The second way of dealing with it is with a weight-integrated BC. Because you'll be needing less weight in the tropics, you can often get your full complement of lead inside of one of those weight-integrated BCs. Try those two things and you'll be light and free in the tropics.
We're here in Bimini in the tropical Western Atlantic because that's where the reefs are. Now, coral reefs are found almost exclusively between the tropics of Capricorn and Cancer. Tropics provided that lovely, warm, clear water that North American tourists love.
And there's the irony. Some of the world's richest ecosystems is found in water that is nearly dead. You see, clear water gets that way because there's nothing in it, no organic nutrients. That's fine for drinking water. We want it sanitized. But how do corals live in it? How does one of the world's richest ecosystems thrive in some of the world's poorest nutrient water?
Well, because their evolutionary adaptation has allowed them to make incredibly efficient use of scarce resources, and they achieve that efficiency by an interlocking relationship among all reef inhabitants, a great chain of life that is as complex as it is rich.
We're going to take a look at some of the ways these reef animals achieve that great efficiency. It can be summarized by a single word: symbiosis. Symbiotic relationships are mutually beneficial. You scratch my back, I'll scratch yours. One of the most important symbiotic relationships is between cleaner fish and their clients. Designated cleaning stations on the reef are devoid of predation. Here, an important function gets carried out. Smaller fish, gobies and shrimp, climb aboard larger fish and feast on parasites and diseased tissue, even inside its gills and mouth. Without getting cleaned of parasites and debris, fish could become unhealthy and die. By far the most important symbiotic relationship on the reef, the one that makes everything else happen, is between coral polyps and the tiny single-cell plants called zooxanthellae that live inside the coral's body. Like terrestrial plants, this marine plant performs photosynthesis, converting the sun's energy into life energy. For each square inch of coral tissue, there are millions of these single-cell plants working like little factories to feed carbohydrates and oxygen to its host coral polyp. Since a coral's health depends upon this plant's ability to carry out photosynthesis, corals require adequate sunlight and proper temperatures, just as plants do. That's why corals can only live in a narrow range of water temperatures. When the ocean gets too hot, the plant living inside the coral's white limestone is expelled, and the coral head looks bleached, like a bare tree without its colorful leaves. The last 2 decades have brought episodes of worldwide coral bleaching that many scientists suspect are linked to global warming.
Tiny coral animals have enough stress in their lives without careless, poorly trained divers coming along and beating them up even more. Now, diver impact on the coral reef is absolutely minuscule compared with the damage being done by anchors, untreated sewage, draglines and other human assaults. Now, as divers, we do have an obligation, like hikers and backpackers, not to leave any trace on this wilderness. As the saying goes, take only memories and leave only bubbles.
And to be a good reef diver, you need buoyancy control. Only if you're neutral and under control can you keep yourself and your gear-laden body off the reef. So let's talk about the steps to achieve proper buoyancy control. Step number 1, be properly weighted. That means being neutral with only 500 psi in your tank and no air in your BC at 15 feet. It also means doing your safety check at the end of your dive so that 800 cubic foot aluminum, which has up to 6 pounds of buoyancy, will be giving you all the lift it has. Step number 2, use your lungs to control your buoyancy while you're swimming underneath. Your lungs contain between 4 to 6 pounds of buoyancy. Use that buoyancy to rise up or sink down slightly instead of your BC. Your adjustments will be much more fine and controlled if you do.
Step number 3, know how to do a flyby to observe. That means turning on your side to look as you swim by, keeping your hands and your arms in. Now, step number 4, if you want to get face to face, as many photographers do, then know how to approach, hover and back out. Maybe using your fins or a single finger on the dead part of the reef to push yourself back. Now, if you think we're being picky and a bit over the top about contact on the reef being unacceptable, we are, because we want our kids and our grandchildren to be able to enjoy what we are fortunate enough to be able to enjoy. So think of them and not yourself.
Since it's more difficult to crush someone you know, let's take a closer look and get to know these animals better. And along the way, answer that age-old question, why the heck does brain coral look like a brain? By answering such a question, you know you're on the right track to begin to understand this world. There's little that is random in nature, and especially in the complex, highly evolved world of coral reefs that have taken the worst nature can dish out for the last 235 million years. Hurricanes, ice ages, even Baywatch reruns. On a coral's surface, you'll see as many patterns as there are species. Each type of coral has a unique way for its polyps to bud and arrange themselves in their limestone houses. In boulder and star corals, the heavy-duty reef builders, each polyp's home takes on an oval shape. When it buds, the new polyp completely separates itself, so you see thousands of little buttons called coral lights, each an individual polyp's home. In a species like brain coral, the budding polyps never completely separate from each other. Instead, they form long lines of partially budded polyps that create wavy lines across the surface of the colony. Location also affects how a coral gets shaped. Some corals form thickets of bushy growth in the shallows where light is plentiful, like the staghorn coral. And the majestic elkhorn coral standing proud. In the shallows, you'll also see small bushels of pencil coral. But the deeper you go, the more you'll see corals begin to flatten out and form plates in order to expose their surface to as much light as possible. Notice how the squirrel corals at 100 feet cascade down so that each plate maximizes its exposure to light. Branching species like this lavender staghorn coral and this field of yellow pencil coral are another reason we want you to be on your best manners down here. They're very easily broken. Though branching corals are the fastest growing, they increase only 10 centimeters per year. The slowest growing are stony corals, increasing only 5 millimeters per year and reach great ages. Some corals on the Great Barrier Reef are 1,000 years old, making corals perhaps the oldest living creatures on Earth.
Well, the sun's about to set here on Bimini, and we're about to start the last part of our day-long dive, the night reef. We're getting in at that transitional period of twilight. It's neither daytime nor nighttime. It's an in-between phase when the light fades and the reef transforms in a marvelous way. Let's go and take a look.
Daytime fish have an increased risk of becoming someone's dinner at dusk because the lower light levels limit their vision. Not so for the big eyes of squirrelfish, soldierfish, and cardinalfish, whose vision is specially adapted to allow it to function in the low-light, no-light environment of the night reef. At dusk, smaller fish begin their nighttime preparations to hide. Fish that swarm close to the reef by day, like these blue tangs, form large schools for protection as they prepare to leave the reef and run a gauntlet of predators into the open ocean. At night, parrotfish find a place to hide, building a membrane cocoon around themselves to hide their scent before sleeping. Obviously, this one didn't build it soon enough and is gobbled up by a green moray. Surgeonfish also stop eating at dusk, move one by one to the ocean side of the reef, and begin forming long single lines that migrate along the reef on paths visible only to them. At night is when mollusks and crabs like this yellow line arrow crab come out to feed. Same for the fireworm it steps over. And rare species like this Cozumel toadfish, found only in the reefs of Cozumel. Flamingo tongue snails inch along. Hermit crabs scuttle about. And bristle stars climb high atop its host sponge to feed on plankton. Fish-eating anemones extend their sticky tentacles. All part of the nighttime performance of the coral reef, where the show never ends. But wait, this show isn't over yet. Sometimes humans can play a role in creating life on reefs rather than destroying it, as you'll see in this segment about an artificial reef. Diving the wreck of the Sapona is like diving into the pages of history. This 300-foot cement-hulled ship was built by Miami developer Henry Flagler back in 1904. Its first mission was as a troop carrier during World War I. After the war, and during the Prohibition era that followed, the Sapona was brought to Bimini to serve as a floating nightclub and casino. This was also the time that America's first airline was established, Chalk's Airline, still the main way for divers to get to Bimini today. Back then, Pappy Chalk, the founder, was not flying divers, but liquor and mobsters back and forth. In 1926, a hurricane blew the Sapona aground. So naturally, the mobs that ran illegal liquor to the U.S. began using the Sapona's hull as a giant holding tank for the hooch that was put in such high demand by the laws of prohibition. During World War II, the Sapona became a target for Navy fighter pilots. As you can see, they did a pretty good job. Today, the Sapona sits half in and half out of the water, presenting divers and snorkelers with a fascinating intersection of the topside and underwater worlds. The sides of the ship are perforated, making it easy for divers to swim in and out of the gigantic wreck. Since it's been aground for so long, the coral and sponge growth are outstanding. Not to mention the fish. Schools of grunts and snappers are, shall we say, very much at home. So are the lobsters and the telesto coral. Since the wreck is so shallow and open, it's great for nearly any kind of photography, close-up or wide angle, if you're snorkeling or on scuba. Don't forget to check the sandy areas around the wreck for nurse sharks and rays. And enjoy those schools of fish. We really hope you've enjoyed this week's show about coral reefs. Most of all, we hope you've learned something about this amazing habitat, the most biologically diverse habitat on Earth.
And by learning about it, you can protect it for future generations.
Until next week, dive safe.
And dive often.